two problems related to Z parameter. In previous class, I have solved three problems related to Z parameter. Now, this is the problem. You have to find out the Z parameter. First of all, the equation of V1 and V2 in terms of Z parameter can be written as V1 is equals to Z11 I1 plus Z12 I2, and V2 is given by Z21 I1 plus Z22 I2. So this is the pair of voltage equation V1 V2 in terms of Z parameter. Now, number one, you have to find out Z11. So Z11 is given by V1 by I1 when I2 is 0. If this I2 is 0, that means only the I1 is present in this circuit. So in this case, you have to find out V1 by I1. So this is the equivalent. If I take this equivalent resistance in the circuit, because this I2 is 0, that means only V1 and I1 present in this circuit. Okay, so V1 and divided by I1 is nothing but a equivalent resistance of this network. Suppose this is A and this is B, so it is nothing but a equivalent resistance across AB. If I take this is A terminal, this is B terminal. Okay, this is the equivalent resistance. Now this equivalent resistance, this R2 and R3 are in series, and R1 parallel R2 plus R3. So it will be R1 into R2 plus R3 divided by R1 plus R2 plus R3. Okay, so it will be R1 into R2 plus R1 into R3 divided by, so it will be R1 into R2 plus R1 into R3 divided by R1 plus R2 plus R3. So this is the Z11 Z parameter. Okay, so this is the Z11 parameter. Now I want to find out this parameter Z12. So here I want to find out Z12. So Z12 is given by V1 divided by I2 when I1 is 0. I1 is 0. So in this case, here this is I2. Okay, this is I2 and this is I1. So in this case, I1 must be equals to 0, and this V1 divided by I2 you have to calculate. So in this circuit only I2 is present, then I1 is 0. So this current will flow through this branch and through this branch and through this branch. So if I take this is as I2 dash, and this will be I2 minus I2 dash. So first of all, we have to find out the voltage V1. So in this case, we have needed this I2 dash. So using current division rule, we can calculate this I2 dash. So using current division rule, we can calculate I2 dash is equals to this resistance R2 divided by R1 plus R2 plus R3 into I2. Okay, this is the I2 dash. Now current through this resistance R1 is given by I2 dash. So V1 can be calculated as the voltage difference between these two terminals of this resistance R1. So V1 can be calculated as I2 dash into R1. Okay, so this is the value of I2 dash. So I2 dash into R1, it will be R1 into R2 divided by R1 plus R2 plus R3 into I2. So this is V1. So it can be written as V1 by I2 is given by R1 plus R2 divided by R1 plus R2 plus R3. So this is the nothing but a Z12. This is Z12. So this is the Z parameter. Z12 is given by R1 into R2 divided by R1 plus R2 plus R3. Now we will deduce the Z parameter Z21. Now number 3, this is number 2, and number 3 we want to calculate Z21. So Z21 is given by V2 divided by I1 when I2 is 0. So in this case it is opposite to this case. Okay, it is opposite to this case. Now what happened? This is I2 and this is I1. In this case I2 is 0. I2 is 0. So only the current I1 is present in this circuit. So this I1 will pass through this branch and through this branch. So if I take, this is I1 dash, and then it will be I1 minus I1 dash. So we can calculate this I1 dash using current division rule. So I1 dash can be written as R1 divided by R1 plus R2 plus R3. R1 plus R2 plus R3. This can be calculated by current division rule. Okay, so I1 dash can be calculated by using current division rule. So I1 dash is given by R1 divided by the sum of this resistance, the sum in the resistance, okay, into I1. Okay, now the current through this resistance R2 is given by I1 dash. So V2 can be calculated as I1 dash into R2. So if I put this value in this equation, then it will be R1 into R2 divided by R1 plus R2 plus R3 into I1. Okay, this is I1. So it is will be V2 by I2. I1 is given by R1 into R2 divided by R1 plus R2 plus R3 is nothing but a Z21. So this is the value of Z21. Here you see that Z12 and Z21 is same. Okay, so this circuit is reciprocal because these two values are same. That means this circuit or network is reciprocal network. Now we will find out Z22. What is the Z22? Here from this equation we can write that Z22 is equals to V2 divided by I2 when I1 is 0. Okay, this is I1 is 0. So all this previous data is erased and we have to take the new one. This is I1. In this case I1 is 0. So this is I1 is 0. So we have to only find out V2 divided by I2. V2 divided by I2 is nothing but a equivalent resistance to this between this terminal, because I1 is 0. So only V2 and I2 is present in this network. So V2 divided by I2 is nothing but a equivalent resistance of between these terminals. So it is nothing but a equivalent resistance across this is suppose C and D, across the C and D terminal. So the equivalent resistance is given by, this is R2 parallel R1 plus R3. Okay, R1 plus R3. So it will be R2 into R1 plus R3 divided by R1 plus R2 plus R3. So it will be R1 into R2 into R2 into R3 divided by R1 plus R2 plus R3. This is Z22 and this not is equal to Z11. So this circuit is not symmetrical, but this circuit is reciprocal. Okay, because Z21 and Z12 is equal, but Z22 is not equal to Z11. So in this way you can find out the Z parameter of this network. Now there are another problem. We will solve this problem 5. So how to solve this problem 5? You see this is the voltage Vz and this is a voltage dependent source. So in this circuit you have to find out the Z parameter also. So here the V1 and V2 in terms of Z parameter can be written as Z11 I1 plus Z12 I2, and it will be Z21 I1 plus Z22 I2. This is the pair of voltage equation V1 V2 in terms of Z parameter. Now we will find out, suppose Z11. So Z11 is given by V1 by I1 when I2 is 0. So when I2 is 0, then this resistance is not in action in the circuit. Okay, so it can be omitted. Then this circuit will be, or network will be, this is I1, this is 5 ohm resistance, and this is 5 ohm resistance, and this is Vz plus minus. So it will be this, and this is 5 ohm resistance, and this also a 5 ohm resistance, and there are a voltage source Vz for Vz. This is plus, this is minus. This resistance is omitted because the current through this resistance is 0, because this is open circuited. Okay, so current through this resistance 5 ohm is 0 because this terminal is open circuited. Now this is the equivalent network of this network when I2 is 0. When I2 is 0. Now this is the current I1. This is the current I1, and there are a voltage dependent voltage source. So this voltage source will produce some current. So suppose this current is given by I1 dash. Okay, this current also we take only I dash. Okay, so this is the circuit. So this current will through this resistance, this current through this resistance, so this current must be equals to I1 plus I dash. Okay, so the current direction in this circuit is given by this, and this is V1, this is plus, this is minus. So first of all we should calculate this Vz. What will be the Vz? The voltage between these 5 ohm resistance. So it is Vz is given by 5 into I1 plus I dash. Okay, I1 plus I dash. So if I take a loop, this is one loop, this is loop number 1, and if I take another loop in this direction, this is loop number 2. So applying KVL at loop 1, we will get, this is I1 and 5. So 5 into I1, so 5 into I1 plus, this is plus, this is minus, so 5, this is will be 5 and Vz, so it will be 5 into I1 plus I dash minus V1 is equals to 0. This is minus, this is plus. So in this case V1 is given by, this is 5, so it will be 10 I1 plus 5 I dash. This is 10 I1 plus 5 I dash. So this is the equation number suppose 2. Now applying the KVL in loop 2. So if I apply the KVL equation at loop 2, so I will go through this terminal. So it is current I dash, so 5 into I dash, so 5 into I dash. This current is also I dash, this current is also I dash, so it is 5 plus 5 into I dash, 5 into I dash. And this is Vz, that means 5 into plus 5 into I1 plus I dash. And this is minus 4 Vz, minus 4 Vz must be equals to 0. So in this loop I start from here, so 5 into I dash plus 5 into I dash plus 5 into I1 plus I dash, that means Vz. This is plus minus and this is minus plus, so it will be minus 4 Vz. So minus 4 Vz. So we have to put this value Vz. So here this is 10 I dash plus 5 I1 plus 5 I dash. This is 4 into Vz. So Vz is 5 into I1 plus I dash is equals to 0. So here it will be, this is 15 and this is 20. So this is 15, this is I dash, this is I dash. So it will be 15 I dash and this is 5 I1. So from this equation it is 20. So 20 I1 minus 20 I dash, so equals to 0. Now this is I dash and this is I dash. So it is minus 5 I dash. This is minus 5 I dash. This also minus 15 I1. 15 I1 is equals to 0. So we need I1. Okay. So in this equation, from this equation we can get I dash is equals to I dash equals to this is 15 I1 divided by 5. That will be a minus. So this is 3. So it will be 3 I1. So this is the equation. I dash equals to 3 I1 minus 3 I1. This is, there is a minus, so it is minus 3 I1. Now if I put this value in this equation number 2, suppose this is equation number 3. Now from 2 and 3, from 2 and 3, so equation number 2 and 3, we will get, this is V1 equals to 10, this is I1, so this will be I1 plus, this is 5 I dash, so 5 I dash, that means 5 into minus 3 I1. Okay, so it is V1 is equals to 10 I1, this is minus 15 I1, so V1 is equals to minus 5 I1, so V1 divided by I1 is equals to minus 5. So this is the Z11. This is the Z11. So in this way you can calculate the Z parameter Z11 in this equation.